we are starting into Chapter 5 today. Lesson 5.1.1. The notes usually take me about 2 days here, but then we usually spend several days working on homework on this one and making sure you guys get the practice you need to figure out how to do these on your own. Okay? There's definitely kind of a learning curve as we work with these identities and how to use them to simplify expressions and whatnot. So that is why, if you look at the homework on page 410, we are starting with the odds. Because I want you to have the answers in the back of the book to check against, to help have an idea if you're doing things right or not. Haven't done next week's lesson plans, but we'll probably look at the evens before we move on to the next lesson. Okay? So that's kind of where we're headed. At the top of these notes, you have a whole bunch of identities, don't you? And these are identities you need to become familiar with. I'm not going to say memorize. You know how the conic section chapter had like all those notes? I usually have a page of notes that I provide on this one. And I haven't dug them out yet this year, but I will. But all these identities will be provided. So it's not about memorizing them, but there is definitely something to be said for becoming familiar with them. Okay? Reciprocal identities. Those should make sense to you. As we look at reciprocal identities, what's the reciprocal of sine? Reciprocal of sine is which one? Cosecant, right? It's the one that begins with the other letter. Switch your S and C. So the reciprocal of sine is cosecant. Well, normally that means if you know sine, you can put it under 1 to become cosecant or vice versa. So these reciprocal identities is just kind of pairing them up. That if you need to change, if you're working in an equation or identity, you need to change sine out, you can change it to cosecant. Or if you have a cosecant, you can change it out to sine. But cosecant's equivalent to 1 over sine, sine's equivalent to 1 over cosecant. And of course, the reciprocal of cosine is secant, so you have those listed. And the reciprocal of tangent is cotangent, so you have those listed. Those are just ways you can switch things in and out of expressions and whatnot. The quotient identities. Those should look familiar to you. We've talked about those a little bit, haven't we? We talked about tangent being, what did we talk about tangent being? We didn't first call it sine over cosine. We said it was, what variables? Y over x. Okay, so, and then I had kind of thrown in, but tangent is sine over cosine. If tangent is sine over cosine, then cotangent is the reciprocal. That means cotangent is cosine over sine. Okay, Pythagorean identities. These are new to you. They are brand new, but we will use them quite a bit. Sine squared theta plus cosine squared theta equals 1. 1 plus tangent squared theta equals secant squared theta. And 1 plus cotangent squared theta equals cosecant squared theta. These are identities. They can be manipulated. Like you can add and subtract things across the equal sign and make them in different forms. So we'll use those. Cofunction identities. So the idea of the cofunction identities, when we look at the graphs of sine and cosine, remember I've graphed those on the same graph before, haven't I? They look like the same graph, except they're just slightly off. Well, they're off by a shift of pi over 2. So these are our cofunction identities. So the sine of pi over 2 minus theta is equal to cosine. You've also got cosine and sine there, so you'll notice cosine and sine are paired up. Tangent and cotangent are paired up, because if you think about it, tangent and cotangent are very much the same graph, other than one's increasing, one's decreasing. But again, they're off by a shift of pi over 2, and then secant and cosecant. For the record, what is pi over 2 in degrees? Pi over 2 is, I heard it, 90 degrees. And I mention that because even though pi over 2 is radians, and we tend to use radians the most, you might pop up and see a 90 degrees in homework. So anytime you see within your parentheses of a trig function, a pi over 2 minus theta or 90 degrees minus theta, that's going to tell me we're using the cofunction identities. And then the last ones we have are the even and odd identities. We've talked about even and odd functions this year. And that has to do with symmetricness and whether or not they're if it's even, it's symmetric across the y-axis. If it's odd, it's symmetric across the origin. So the even and odd identities help us if there is a negative on the variable. What is it equal to? For instance, sine of negative theta is equal to negative sine theta. But that's not true for all pieces, okay? Sine is an odd function, which is why it's equal to the negative. Cosine of negative theta is equal to positive cosine. So if you have a negative on the variable there, you can just drop it off and it's equal to positive cosine. That one's because it is symmetric across the y-axis. It's an even function. Tangent, cotangent, and cosecant are all odd functions. They're equal to the negative. Secant is equal to the positive. So again, you'll have this list to use. Now, key comment before we start looking at some examples here. The idea with the identities is that trig functions can be replaced with other equations that they are equivalent to in order to simplify or solve. We're simplifying expressions. We're solving equations. This might be my plan for tomorrow. I haven't decided. But if you glance at the back of your notes, those expressions can all be simplified down into much simpler trig functions, where you don't have multiple trig functions multiplied, added, subtracted, divide. We're going to practice simplifying those, there's a learning curve to it. It's going to take practice. Now, let's look at some of these examples down here. You guys still have your identities in front of you. I'll go back and forth from page to page some. But let's look at example 1. Find sine of theta and cosine of theta if tangent of theta is 5 and cosine of theta is less than 0 by using the identities rather than reference triangles. So we would have had a problem like this on our last chapter 4 test, where it said, okay, here's, information. Tangent's 5, cosine is less than 0, find these other two trig functions. We're going to use the identities at the top of our page. Now, my goal is to find sine and cosine. I'm given that tangent is 5. Remind me, what does cosine theta less than 0 mean? Means that cosine is what? Negative? Okay. We know tangent. We want to find sine and cosine. We're going to have to do this one at a time. Thoughts on an identity from up above, and I'm going to backtrack for a moment, that might connect tangent to either sine, cosine, or something that relates to sine or cosine. And I guess the direction I want to point you is to our Pythagorean identities. Okay? The common mistake here would be to go for a quotient identity. But just because we know tangent is 5 does not mean 5 over 1 and sine is 5 and cosine is 1. That's not how this part works. So if we look at Pythagorean identities, what could we use here based on the fact we know tangent? In other words, there's going to be a few steps here. But based on the fact we know tangent, is there a Pythagorean identity that involves tangent? And there is, isn't there? Right there, 1 plus tangent squared equals secant squared. So that's a Pythagorean identity we're going to use. Now, as I say that, that's not the only way we could do this problem. But this is an option. So, let me write this out as 1 plus, wait, which way is it? I gotta get my 1 plus tangent squared theta equals secant squared theta. Okay. What do I know I can fill in? We know tangent here. So 1 plus, okay, it's tangent squared theta. So that is tangent theta squared. What's tangent theta equal to? 5. So this means we're going to do 1 plus 5 squared. And that is officially going to be equal to secant squared. What is 1 plus 5 squared? Five squared is 25, plus 1 is 26. So I have 26 equals secant squared. Obviously, we can flip those two sides, and I probably will here. How do I solve? If you're not sure or hesitate, my question to you would be, if this said x squared equals 26, how would you solve? You'd square root both sides, yes? So if it says secant squared equals 26, how can you solve? We can square root both sides. So if we square root both sides, the square root of secant squared is secant. The square root of 26? Square root of 26. Officially, I just took the square root in an equation setting. So officially, we have to consider plus or minus. Now, I'm going to claim I know whether it's positive square root of 26 or negative square root of 26. What tells me in this particular problem whether it's positive or negative? Cosine is negative. And if cosine is negative, what's the reciprocal of cosine? Secant. So if cosine's negative, then secant has to be negative. So we know right there that secant of theta has to be negative square root of 26. And that's because cosine is negative. So because cosine is negative, secant is negative. Now, I found that lovely piece of information. Was that even asked for me to find? No. The request was to find sine and cosine. Well, what do I know? If I know secant is the negative square root of 26, what do I know about cosine? What's the connection between secant and cosine? It's reciprocal, yes? And technically you guys knew that before today, right? You know cosine and secant are reciprocals. However, if you forgot that minor detail, it's also in your quotient identities, right? Or not quotient identities, excuse me, reciprocal identities. In that cosine theta is equal to 1 over secant theta. So if cosine theta is equal to 1 over secant theta, then cosine theta is equal to 1 over the negative square root of 26. I did not set my paper up very well. My apologies. Because I still have to have a little bit of room over here to find our other piece.
Do we have to rationalize that? Or?
Notice I boxed it, or I circled it. So no, you are not required to rationalize. And I can't for sure say what's in the answer key, but I'm noticing if I did not rationalize here, you're probably okay not to rationalize. Okay, so we used a Pythagorean identity, and then technically we used a reciprocal function, a reciprocal identity. Now, I know tangent. I was given tangent. I now know cosine. I need to find sine. We could go two different ways here. So glance up at your identities. If I know tangent and cosine, how could I find sine?
Pythagorean identity.
Okay, could we use another Pythagorean identity? We know cosine. Could we put that in the top one and use it to find sine? That is one option. What's my other option? Could we use a quotient identity now? We can. Okay, now because I know tangent and cosine, I could use the quotient identity since I know two of the three. Does it matter what you use? It does not. Okay, I was going to use quotient identity to show that option, but if you'd rather try Pythagorean identity and meet me in the end, then that's fine as well. So the identity I would use is that tangent of theta is equal to sine of theta over cosine of theta. And again, if you want to go with Pythagorean identity, more power to you. It works. It's perfectly fine. So tangent of theta is 5 equals sine of theta divided by cosine of theta, which is a negative of 1 over square root of 26. It doesn't look pretty for the moment, but that's okay. We'll rectify that soon enough. How do I solve for sine? Like, think of sine as your variable here. How do I solve for sine? If it's sine divided by that lovely number, then we want to multiply by that lovely number. Does that make sense? It's sine divided by this fraction. So in order to get rid of that fraction, we're going to multiply by the fraction. And if you multiply one side by the fraction, we're going to multiply the other side. So I'm going to end up doing 5 times negative 1 over square root of 26. What is 5 times negative 1 over square root of 26? Negative 5 over square root of 26, because 5 as a fraction is 5 over 1. So 5 times negative 1, so negative 5 over square root of 26. Okay. What questions can I answer here? Yeah.
So it doesn't matter like how we do it as long as they're all related. So like I could have used the Pythagorean identity there.
Yep.
Got the same answer.
Yep. Yep. You can use, yeah. And I won't go as far as saying it doesn't matter, but there are multiple right ways to get there. So yes, Pythagorean identity would have worked. The only thing we couldn't have done here is we could not have started with quotient identity, because you have to know two of the three to use the quotient identity. But other than that, we could have never used a quotient identity and used two Pythagorean identities, and that would have worked. So I will say the hardest part about these problems is when you go to do them on your own, seeing the connections. That's the part that is going to be a little bit harder to figure out, okay, and take a little bit longer, which is why we're going to spend several days on this lesson. Okay, let's look at example 2. Given that cosine of theta equals 0.03, redo, given that cosine of theta equals 3400ths, 0.34. Find sine of theta minus pi over 2. Okay. As I read that problem, I mean, obviously I see my given here, right? I'm given that cosine equals 0.34. My job is to find the sine of theta minus pi over 2. This is where you have to look at your list of identities and something has to pop out at you that this is the direction we need to go. So we're given a cosine, okay, yeah, whatever. And then we're asked to find sine of theta minus pi over 2. What pops out to you guys from our identities?
Cofunction.
Cofunction identities. Now, it may not match up exactly, but is it similar enough to grab your attention? That's what I would like to think. They want us to find sine of theta minus pi over 2. We have an identity for sine of pi over 2 minus theta, don't we? If we can make that connection, then we're going to be headed in the right direction. And so I always hesitate with what's the best way to explain this one, because I struggle with how to put work down for this one. It's one of those that I can more see, and I can kind of put some work down, but okay, I'm going to start with what they're asking us to find. They're asking us to find sine of theta minus pi over 2, correct? Now, this doesn't look exactly like what's on our identity list, does it? So what would make it look more like what's on our identity list? If you take the pi over 2, the theta and the pi over 2, and you flip them. So if I flip them, just trying to work my way there, and I put the pi over 2 first in my parentheses, it's a what type of pi over 2? A negative pi over 2. And then the theta last, it's a plus theta. That's closer to the identity, isn't it? What's it off by? It's off by a negative, right? Don't both of these signs have the wrong, they're basically, we have the wrong sign, don't we? We need this to be positive pi over 2. We need this to be minus theta. What happens if you factor a negative out? And I don't know if I can write it and make it look right or not here, but let me try. If I factor a negative, so it's a negative, and then it's going to be pi over 2 minus theta. That looks kind of weird because I did parentheses inside parentheses. But if I factor that negative out, what do my even odd identities say about a negative in the sign? Because I just factored the negative out of both of these. A negative in sign. Whoops, that's not what I wanted to do. Wrong button. So right here, if you have a negative inside the sign, what happens when you take that negative out of the variable? It becomes a negative out front. And so what we can basically rewrite this as is the negative of sine of pi over 2 minus theta. According to our identities, what does it say about sine of pi over 2 minus theta? According to my cofunction identity, sine of pi over 2 minus theta is equivalent to what? Cosine of theta. Now we have the negative out front, so it's negative cosine of theta. So those replaced each other. This is equal to negative cosine theta. Did we have some information about cosine theta? Cosine theta was what? 0.34. So if I've gotten to a point that this is equal to negative cosine theta, what value is this equal to then? The negative of cosine theta, but cosine theta is 0.34, so it's equal to negative 0.34. Okay. Again, the connection to notice early on is that, okay, there's definitely a connection between cosine and sine of theta minus pi over 2. It's just that extra negative in there kind of threw things off. Again, I struggle with how to write that one down. I think you can, some of you are going to be able to just see that one and not feel the need to write it down as much. But are there questions I can answer there? Okay. Well, let's go to example 3. Now, as we look at example 3, I'm going to make the suggestion that example 3 is going to be worked a lot like example 1. Example 3 is going to be worked a lot like example 1. They're asking me to find secant and cotangent given that sine is negative 2/3 and tangent is greater than 0. For the record, tangent being greater than 0 just tells me that tangent is positive, which will definitely affect my cotangent answer. Sine is equal to negative 2/3. Well, if you want to go ahead and make the notice, that tells me that sine is negative. Is that going to be able to put me in a quadrant eventually? That's going to be able to put me in a quadrant if tangent has to be positive and sine has to be negative. I mean, we could even go ahead and talk about that. All students take calculus. Tangent has to be positive. So if tangent has to be positive, that gets rid of sine and cosine quadrants. Sine is negative, so that gets rid of all. So we're going to be down there in the quadrant where tangent is positive and cotangent is positive, but everybody else is negative. So we can still use chapter 4 material, right? Okay, guys. We know sine. What would you like to use to find somebody else? Go back to your identity list. What are options?
Could we do one of the Pythagorean identities?
We could do a Pythagorean identity again. Based on the fact we know sine, we could definitely do the top Pythagorean identity, right? Sine squared plus cosine squared equals 1. What's the other Pythagorean identity we could technically do if we wanted to? You could technically take the reciprocal of sine, and you could do the cosecant squared equals 1 plus cotangent squared. And this is where I'm going to say there's not just one right way to go with this. You could start with either the top or the bottom Pythagorean identities. I mean, technically you have to come up with cosecant first. But if we know sine, we know cosecant because they are the reciprocals, right? I don't know, which one did you have in mind, Ethan? Were you looking at the top one?
I was thinking the top.
Okay, and I think that's the more obvious way to go. But I'm just saying that there's not just one right way to go on these. We'll definitely find that. Okay, so let me come over here and try and give myself some room. Sine squared theta plus cosine squared theta equals 1. Fill in what you know. Cosine is negative 2/3, so, excuse me, I just said cosine, didn't I? Sine is negative 2/3, so sine squared means I'm going to be doing negative 2/3 squared plus cosine squared theta is what I'm going to be finding. So when it says sine squared theta, you're taking whatever sine theta is and squaring it. What is negative 2/3 squared? Two times 2 is 2, 3 times 3. Oh my gosh. Did I just say 2 times 2 is 2?
Yeah.
2 times 2 is 4. 3 times 3 is 9. A negative times a negative is a positive. Positive 4/9 plus cosine squared equals 1. It's going to be rough. How do I solve for cosine squared? If it's 4/9 plus cosine squared, what do we need to do? To get cosine squared by itself, so that's like thinking if this is 4/9 plus x squared. How do I get x squared by itself? We're going to take the positive 4/9 and we're going to subtract it. Subtract 4/9 on the left, subtract 4/9 on the right. 4/9 minus 4/9 cancel. Cosine squared theta equals, what's 1 minus 4/9? 5/9, right? Because 1 is 9/9. 9/9 minus 4/9 is 5/9. If cosine squared theta is 5/9, how do I get rid of the squared on cosine? Take the square root. The square root of cosine squared theta is cosine theta. What's the square root of 5/9? What's the square root of 5? I don't want a decimal answer. Square root of 5. What's the square root of 9? 3. So how can I write this? Square root of 5 over regular 3. Since I just took the square root in an equation setting, we are officially going to say plus or minus for the moment. But we know if that's positive or negative, don't we? Which is it? We know tangent's positive and sine's negative, so that put us down here in quadrant 3. So because of this right here, we know that cosine is negative square root of 5 over 3. Kind of like earlier, we did all that work and we still don't have an answer. But here's what I'm going to say. The short version is if cosine, oh, don't do what I just did. You should always have the variable in there, cosine theta. If cosine is negative square root of 5 over 3, what do we know? If cosine is this, okay, secant is the reciprocal. So secant is negative square root of 5 over 3. I am perfectly fine with you just jumping straight to that. Saying, okay, I know cosine is this, secant is the reciprocal. But did I write the reciprocal? It is rough. Okay, negative 3 over square root of 5. My goodness. Okay, sorry guys. Now, officially, we could have used the idea that secant theta is 1 over cosine theta. We could have used that officially. And so we could have said secant theta is 1 over negative square root of 5 over 3. But then you would have ended up right here at the same spot. Now, okay, I'm running out of time, I know, but there's secant. What else did I need to find? Cotangent. What are options to find cotangent?
Quotient identity.
Okay, quotient identity would work perfectly well because we know enough there. Because we know sine, we know cosine. Or you could go with Pythagorean identity again. I personally, I'm just going to go quotient identity. So cotangent is equal to cosine theta over sine theta. Cosine theta is negative square root of 5 over 3. Divided by sine theta, which is negative 2 over 3. How do we divide fractions? Carefully. Multiply by the reciprocal. So negative square root of 5 over 3. If it's dividing by negative 2/3, it's going to multiply by negative 3/2. My 3's cancel. My negatives multiply to be a positive. And I have square root of 5 over 2. Try that again and not try and go over my 2. Again, there are other ways you can get to these correct answers. Now, with this in mind, guys, okay, we've started looking at this. You can look at a few of the odds in homework. Tomorrow, remember, I am not here. I have considered leaving the backside of notes with you guys to at least start looking at them, with the idea that I'm going to have to give you guys lots of help on the homework anyways. I know how this homework goes. So, I don't know. I'll leave sub-plans and come up with something, but it very may possibly be looking at the notes.
So homework is not due tomorrow.
No, homework is definitely not due tomorrow. If I'm thinking what I do right now, if I leave the next part of the notes, then we'll start talking about homework questions on Monday. But I may not check it until Tuesday. I may do something like that. I'll let you know what I'm doing. Okay? So I'll have a post on Schoology with my sub-plan so you guys know what I'm thinking. And as always, you can email me with questions.
Sergeant?
Yes.